Peace and blessings of Allah be upon you, our highly respected viewers. You are welcome to the Education Committee tutorials organized by Muslim Student Society of Nigeria, Kano University of Science and Technology, WUDIL branch. So after this, let's take a look at Venn diagram of 3 sets. Now, assuming we are having 3 sets, let me just draw the diagram. 3 sets, like this. Just want to make interpretation. A, okay, assuming this is the universal set. This is a set B, and this is a set C. Okay, here is this place, as you see, is the place that join A, B, and C, which is the intersected place. A intersection B, intersection C. While if you take a look at this place, it's A and B, but not A and B only. It's just a portion, some portion of A and B, this place. Because here also, if I kill in this place, you're going to see that even this A intersection B intersection C is part of A and B. But if I am to find only this place, I will just use, get the value number of what you call it, A intersection B minus the intersected element of all the 3 sets. That is to say, this place, this very place, let me write it here, is just called number of A intersection B. That is only A. In some instance, some language, we can call it only A intersection B, and it is given as the value of A intersection B given minus the whole intersection, A intersection B intersection C. That is, you are going to have this place. Likewise, you apply the same thing here. Look at it, B intersection C. So to get this place is called number of what? B intersection C. Use the same language, that is the value of B intersection C given minus the whole intersection. Also the last one, which is A intersection C. Look at it here, let me just denote it. It's also called A intersection C. Sorry, intersection C. Which is A intersection C minus the whole intersection. That is where we are going to have this place. So this place is called number of A intersection B. This place is called number of B intersection C, while this place is called number of C or E intersection C, the same thing. So having now this place, the remaining part is this and this and this. Let me just explain it here. Now, if I take this place, you see, it's a place where it contains only A without the combination of B and C. So it is known as number of A only, while this place is known as number of B. This place is known as number of C. So now let me interpret how to find it. Number of A. For you to find what is in here, you have to take the value of A given minus the summation of all the intersected elements in A. That is number of A intersection B plus number of A intersection C, then plus all the intersection A intersection B intersection C. Summation. Now also number of B, let's take number of B. The same thing. That is the value of B minus the summation of all the intersected places in B. That is number of A intersection B plus number of B intersection C plus all the intersection. The last one, which is number of C, the same thing. Sorry, number of C, which is equal to C minus the intersected values in C, that is number of A intersection C plus number of B intersection C plus all the intersection C. So this is a Venn diagram with 3 sets, how to calculate it. And this place is just A union B union C complement. That is not in A, not in B, and it is also not in C. So let's see the arithmetic formula for this. Let me just manage it here. Let me manage it here. A union B union C complement. That is the summation of everything that is here is the same, is equal to the universal set. That is, look at it, number of A plus number of B plus number of C, this one, then plus this one, number of A intersection B plus number of B intersection C plus number of A intersection C plus all the intersection A intersection B intersection C plus this one A union B union C complement is all equal to universal set. Like in the first one that have 2 sets, if something you are asked to find one of these things in this 3 Venn diagram, you just use this formula to find the unknown value. Let's take a look at one example on this. In a town of 250 people, 20 are speaking, let me write, 20 speaks Yoruba, 29 speaks, speaks, 29 speaks Kanuri, and can I use 80? Yeah, 80 speaks. 80 is much? No, it's not. Let me use 60. Sorry. 60 speaks Hausa. If 15 speaks Hausa and Yoruba, 8 speaks Kanuri and Yoruba, and let me set 8 here, 5 speaks Kanuri and Hausa. I use Kanuri, yes, Kanuri and Hausa. Find those speak none of the 3 languages if 12 speaks all the 3 languages. Okay, now let's take a look at this example. It says in a town of 250 people, 20 speaks Yoruba, 29 speaks Kanuri, and 60 speaks Hausa. If 15 speaks Hausa and Yoruba, 8 speaks Kanuri and Yoruba, 5 speaks Kanuri and Hausa, find those that speaks none of the three languages if 12 speaks all the three languages together. As usual, the first thing to do here is to what? To collect the data. Solution. And if you see, it's just a set of what? 3. That is speaking Hausa, speaking Yoruba, and speaking Kanuri. Now collecting the data, as I said before, this is what? The universal set. Our universal set is 250. I will let Yoruba to be Y, and Y is given as what? 20. Also, Kanuri K, which is 29, Hausa H, which is 60. Also, let's see this. It says 8 speaks Kanuri and Yoruba. That is Kanuri and Yoruba is equals to 8. 15 speaks Hausa and Yoruba. Hausa and Yoruba is 15. Then the last one, 5 speaks Kanuri and Hausa. Kanuri and Hausa is equals to 5. Says, find those that are speaking none. Hausa Union, Kanuri Union, Yoruba. We are to find this. And also we are given what? Those that are speaking all. H intersection Y intersection K is equals to what? It's given us what? 12. So now having our data, the next thing is to represent this data in a Venn diagram, then we solve for this. Now let this one to be X. So let's draw our Venn diagram so that we see how to represent it. So drawing our, let me manage this place to draw it. We have this, and we have this one. This is our Venn diagram. This is for H, this is for Y, and this is for Kanuri. As I said, the first thing to write here is what? The intersected value. And here the intersected value is what? 12. So you write 12. Next thing is what? This one. H intersection Y. That is, we are given as what? 15. But we are not going to write 15. As I explained, you have to subtract whatever you are given as the intersected value with the whole intersection. That is 15 minus 12. We are going to have 15 minus 12, 3. Now Y and K. Why is Y and K? This one. That is 8 minus 12 here. So we're going to have what? 8 minus 12 minus 4, right? Yes, minus 4. Also the last one, which is H and K. H and K is 5. So 5 minus 12 is minus 7. So what next? This one, only H. As I said, is going to give you like only H. The value of H, which is 60, minus all the intersected values. That is 3 plus 12 plus minus 7. So we're going to have 60 minus 3 plus 12, 15. 15 minus 7. So we're going to have 15 minus 7. What is 15 minus 7? 60 minus 15 minus 7. 15 minus 7. Is it 8? Yes, it's 8. So 60 minus 8 here is just 52. So the number of H only is 52. What next? Then Y only. I assume Y only. The value of Y, which is 20. So we're going to have 20 minus 3 plus 12 minus 4. 3 plus 12, 15. 15 minus 4 is what? 15 minus 4 is 11. Then this minus this is 9. So this value here is 9. The next one, let me do it here. Number of K. That is values of K, which is 29 minus all the intersected in K. We have minus 7 minus 4 minus 12, which is 29 minus 7 minus 4 is minus 11. Minus 11 minus 12 is minus 23. That is minus 11 minus 12. That's minus 23. So this is going to give 29 plus 23, which is 52. Here is also 52. So then our x, just look at our x here. So having our values here, the next thing is just to sum everything here and equate it to the universal set. As usual, we are going to have, let me put it here, number of h plus number of y plus number of k plus number of h intersection y plus number of y intersection k plus number of h intersection k plus all intersection h intersection k intersection y plus their complement h union k union y, all complement is all equal to the universal set. Number of h here is 52. 52 plus 9 plus 52 plus 3 plus 12, yes, plus minus 7 is minus 7, minus 4, then plus x is equal to universal set, which is 250. Now let's do it. This one plus this. And this one, 50 plus 9 plus 52 plus 3 plus 12 minus 7 minus 4 is now equal to, let's do it, it's 50 plus 9 plus 52 plus 3 plus 12 minus 7 minus 4 is equal to 115 plus x, which is equal to 250. Now we just collect like term by saying x is equal to 250 minus 115, which is equal to 135. So this 135 are number of people who do not speak Hausa or Yoruba or Kanuri. So I think we solve only one example on this. So with this we are done with set theory.